Hi everyone, myself Saranya, Assistant Professor, SNS College of Allied Health Science, Coimbatore. Today we are going to discuss a topic on basics of priming solution. So prime is a solution that is used to substitute the blood to provide a safe hemodialation, fill the circuit line and the DR the circuit. To give an adequate flow rate can be easily achieved without air embolism can be done with the help of the priming solution. So it will be coating the circuit. So how the ideal prime should be is an tonicity. Tonicity refers to a concentration of the solution that determines the direction of extension of diffusion. It does not cause a red blood cell lysis, third shifting or an edema to the patient. Here are the properties of an ideal prime. There are various solutions which is hypotonic, hypertonic and isotonic solution. Hypotonic refers to lesser concentration. It has a lower concentration of the solution outside the cell than inside the cell. For example, it's a distilled water where the concentration is less than that of plasma. This can lead to hemolysis, severe intravascular or interstitial fluid shift, circulatory insufficiency and edema. Next one is an hypertonic solution. It has a higher concentration as that of a plasma. For example, it is a dextrose 0.9% of normal saline. So it can cause an erythrocyte crenation or an RBC lysis. Next one is isotonic solution. It has the same concentration as that of plasma. From here it knows that we are using an isotonic solution as a prime for cardiopulmonary bypass. It is a normal saline. It prevents a fluid shift, electrolyte imbalance, prevent lysis, maintain the colloid osmotic pressure, interstitial and intravascular fluid balance can also be maintained. Electrolyte composition. The electrolyte composition of a priming solution should meet as that of a plasma. It provides a fluid that should be capable of mixing with the blood to carry the oxygen and remove the carbon dioxide and maintain an environmental homeostasis. So normal serum concentration should be an sodium, potassium, chloride, calcium, phosphorus, magnesium, glucose and serum osmolarity. So these concentration has to be matched in the priming solution what we are using. The sodium is 136 to 145 milliequivalents per liter, potassium 3.5 to 5 milliequivalents per liter, chloride 100 to 106 milliequivalent per liter, calcium 8.5 to 10.5 milligram per deciliter, phosphorus 3 to 4.5 milligram per deciliter, magnesium 1.5 to 2.5 milliequivalents per liter and glucose 70 to 130 milligram per deciliter, serum osmolarity 285 to 295 milliosmoles per liter. Colloid osmotic pressure, which is called as osmolarity, it states the number of dissolved particles contained in a specific unit or a volume of fluid. Here we are mentioning about the proteins which are present on the plasma. So the osmotic pressure of a priming solution to optimally be as same as that of plasma. So we are using a colloid solution which is called as human albumin, that is a plasma, that is a protein molecule. The normal colloid osmotic pressure is 25 mmHg and this will drop on bypass once you do one hemodilution. So the evidence of low colloid osmotic pressure improves a good renal function, although the colloid osmotic pressure is very much important to avoid a fluid shift or interstitial fluid buildup. So the building of fluid in an interstitial region prevents the removal of waste products. So the colloids are the large particles in the solution of 40,000 to 50,000 Daltons. So the colloids increase the colloid osmotic pressure that force the capillaries by the arterial blood pressure and re-enter the vascular space in search of equilibrium. So the colloid osmotic pressure can be calculated with plasma volume into 25 mmHg by the priming volume. How to calculate the priming volume? Priming volume is equal to patient weight into 20 ml. This volume is very much necessary to maintain or adequate venous reservoir volume in the reservoir to avoid emptying of reservoir and air entrainment into the circuit. And the length of your tubing and the calibration also depends upon the priming volume. Here are the major constituents and the normal concentration of the plasma and the interstitial fluid where the priming solution has to meet this criteria, which is equal to 154 milliequivalents per liter. And here I have mentioned about the different size of tubings and the per centimeter and per foot where the priming volume can be occupying in the tubing. So approximate volume delivered per rotation of the pump is half an inch for the tubing, that is 1 by 2 inch tubing, it is 45 ml, 3 by 8 inch, it is 26 ml, 1 by 4 inch, it is an 12 ml, and 3 by 16 inch, it is a 6 ml. This much of fluid will be going out from the pump to an oxygenator by a single rotation. There are various priming solutions we are using according to the patient needs and the surgical preferences. We are using a crystalloid solution. The solution is that of plasma, a colloid solution which contains an albumin or a protein, and the blood, it is an autologous blood. We are using a patient's own blood instead of a prime. Here there are various combinations to be used according to the patient's needs. Thank you for listening.